Have you ever stared into the night sky and wondered about the mysteries it holds? The vast universe, a canvas painted with stars and galaxies, is an enigma that scientists have been trying to unravel for centuries. It's a realm of cosmic wonders where the ordinary meets the extraordinary, where questions often outnumber the answers. Among these countless celestial puzzles, there's one that has captivated astronomers and astrophysicists alike: the enigma of quasars. These cosmic powerhouses are not just any ordinary celestial bodies. They are the universe's lighthouses, the brightest objects we know of, outshining even the brilliance of entire galaxies. Yet they are also among the most mysterious entities in the cosmos, their true nature and function still largely unknown. Today, we're diving into the fascinating world of quasars, the brightest objects in our universe. So what exactly are quasars? Well, they are among the most mysterious and fascinating objects in the cosmos. Quasars, or quasi-stellar radio sources, are incredibly luminous objects found in the distant universe. Imagine a celestial body that outshines all the stars in its galaxy combined. That's a quasar for you. Now, what could possibly power such an astonishingly bright object? The answer lies within the heart of the quasar, a supermassive black hole. Now, when we think of black holes, we usually imagine an all-consuming vortex of darkness, not a beacon of light. But here's the catch. As matter falls towards the black hole, it forms a swirling disk of gas and dust, known as an accretion disk. The intense gravitational pull of the black hole heats this disk to such high temperatures that it glows incredibly bright, outshining entire galaxies. But quasars are not just bright. They are also some of the most energetic objects in the universe. The energy generated by a quasar is mind-boggling. To give you a sense of scale, it's around 60 times greater than the energy released by nuclear fusion in stars. Quasars are not only fascinating because of their extreme brightness and energy, but also due to their distance from us. The light we see from quasars has been traveling for billions of years across the cosmos. This means that when we observe quasars, we are looking back in time to a period when the universe was much younger. Quasars provide us with a unique window into the distant past and the early universe. By studying them, we can learn more about the evolution of galaxies and the role of supermassive black holes in shaping the cosmos. These celestial powerhouses are not just bright, they are also relentless engines of energy. Now that we know what quasars are, how do they work? To understand the workings of a quasar, we need to take a closer look at its core. At the heart of every quasar resides a supermassive black hole. These aren't your garden variety black holes. They're enormous, ranging from millions to billions of times the mass of our sun. Now let's imagine a hapless star straying too close to this black hole. The star is ripped apart by the black hole's powerful gravitational pull, its matter spiraling inward, forming what we call an accretion disk. Picture a cosmic whirlpool with the black hole at the center and matter spiraling inwards at breakneck speed. As this matter spirals closer and closer to the black hole, the particles within it collide with one another at high speeds, generating intense heat. This heat then radiates outward, causing the accretion disk to glow and shine brightly. But that's not all. The extreme conditions at the edge of the black hole also generate powerful jets of particles, shooting out perpendicular to the accretion disk. These jets can extend for millions of light years, creating a beacon that can be seen across the universe. The combination of the glowing accretion disk and the powerful jets is what we observe as a quasar. But the energy generated by this process is mind-boggling. In fact, the energy released from matter falling into a black hole is about 60 times greater than the energy produced by nuclear fusion in stars. To put that into perspective, if we could harness the energy from a single quasar for just 1 second, it would be enough to power all of humanity's energy needs for about 1 million years. So there you have it. Quasars, the universe's ultimate powerhouse, a cosmic lighthouse driven by supermassive black holes and the unstoppable force of gravity. This energy release is 60 times greater than nuclear fusion in stars, making quasars the universe's ultimate powerhouse. Quasars are not just fascinating, they also impact galaxies in significant ways. You see, quasars are the celestial equivalent of celestial wrecking balls. Their immense energy and gravitational pull have the ability to wreak havoc on their surrounding galaxies. Let's delve into how this happens. As quasars consume matter, they generate immense heat. This heat energy is so intense that it can violently expel gas from the surrounding galaxies. This expulsion of gas is not just a casual cosmic event. It plays a pivotal role in the life cycle of a galaxy. Gas in a galaxy is the primary ingredient for star formation. Stars form when dense clouds of gas collapse under their own gravity, igniting nuclear fusion reactions at their cores. However, when quasars drive this gas away, it effectively puts a stop to the birth of new stars. Now, galaxies are not static entities. They are dynamic, ever-changing systems where stars are constantly being born and dying. Without new stars to replace the old ones, a galaxy begins to fade. Over time, as more and more stars exhaust their nuclear fuel and die out, the galaxy becomes a shadow of its former self, a barren cosmic wilderness. This is how quasars, with their violent expulsion of gas, can lead to the ultimate demise of a galaxy. But it's important to remember that this is not an overnight process. The death of a galaxy at the hands of a quasar is a slow, gradual process that takes billions of years. It's a cosmic ballet of destruction and creation, where the very forces that give rise to galaxies can also lead to their end. This is the paradox of quasars. They are both creators and destroyers. They give rise to brilliant celestial displays as they consume matter and radiate energy, but they can also bring about the downfall of their host galaxies, turning vibrant cosmic metropolises into ghost towns. In essence, quasars have the power to kill galaxies. But what about our own galaxy, the Milky Way? The connection between the Milky Way and quasars is a fascinating one. It's like trying to unravel a cosmic detective story. Let's dive into that. It's not entirely certain if every galaxy goes through a quasar phase in its lifetime. However, there's compelling evidence to suggest that our very own Milky Way galaxy might have had a quasar phase in its distant past. A quasar phase, as we discussed earlier, is a period of intense activity where a supermassive black hole at the center of a galaxy gobbles up matter at an extraordinary rate, creating a radiant beacon of energy that outshines the rest of the galaxy. In the case of the Milky Way, we know there's a supermassive black hole at its center. Sagittarius was not always this calm. Astronomers have found evidence of massive outbursts of energy in the Milky Way's past. These outbursts, they believe, are the echoes of a time when our galaxy's black hole was much more active, possibly even a quasar. Consider this. The energy from a quasar is so intense that it can blow away the gas and dust needed for new stars to form. If our Milky Way went through a quasar phase, it could explain why our galaxy's central regions have fewer young stars than expected. So while we can't say for certain, it's possible that the supermassive black hole at the heart of our galaxy is a sleeping giant, a relic from a time when the Milky Way blazed as a quasar in the distant cosmos. The supermassive black hole at the center of our galaxy may be a remnant of that ancient quasar. Quasars, the universe's brightest and most energetic objects, are truly a testament to the awe-inspiring power and mystery of the cosmos. These colossal structures, with their supermassive black holes at the core, consume vast amounts of matter and generate energy 60 times greater than nuclear fusion in stars. Their intense energy not only lights up the cosmos, but also violently heats and expels gas from galaxies, preventing star formation and ultimately leading to the galaxy's demise. Our own Milky Way may have had its quasar phase, with the supermassive black hole at its center potentially being a remnant of that ancient period. So, if you're intrigued by these cosmic powerhouses, why not delve deeper? Brilliant.org offers a free lesson on black holes and quasars, along with hundreds of interactive science and technology lessons. Stay curious, keep exploring, and remember, the universe is full of mysteries waiting to be discovered.